In this video, I'll be going through the Epsilon Delta proof of a limit in this form, where the limit as x approaches a real number approaches infinity. I'll be using this limit as an example. This one's very similar, very similar to my video on when the limit as x approaches a, f at x approaches infinity. The only one small difference is what I will highlight today. So this is how we want to write our want to show. We want to say for any m in the reals, right, there exists a delta greater than 0, such that 0 is less than x, which is less than delta, implies, and this is the difference, we now need to show that 1 over x is less than m, right? Because this is saying for any arbitrarily small value, that small value is still going to be greater than the function once we choose our delta. So that's what we want to do. Okay, so let's, all right, again, this is our proof. All right, let m be element of the reals. Take delta as something we don't know yet. Well, let me just move this a bit to the... Okay, now we let x be a real number. Assume that 0 is greater than x, which is less than x, which is less than delta. Now we have to somehow prove that negative 1 over x is less than m. Okay, so let's see. We know x is less than delta, and we want to show that negative 1 over x is less than m. Okay, so we can also see that this also means if you multiply both sides by negative 1, we know that 1 over x has to be greater than negative m. Recall that if you multiply both sides by negative 1, you have to multiply the inequality by negative 1 as well, which just flips it, right? And then if we multiply both sides by x and then divide by negative m, we get 1 over m is greater than x. And okay, hold on a minute. Let's see. X is less than delta. And x is also less than 1 over m. So we can just set delta as negative 1 over m. And then we've proven that x is less than negative 1 over m, which proved our original statement here. Perfect. So let's do that. Let's just have delta as negative 1 over m. And I'll write this a bit differently. I'll write this as this implies x is less than negative 1 over m, which implies negative x is greater than 1 over m, which implies m is greater than negative 1 over x. And that we've proven our statement. Therefore, negative 1 over x is less than m. And that's the end of the proof.